Hey, I'm Rob Taylor, visual artist and general maker of things, and this is the second video in the Battle Rifle Build Skills series, and this time we are going to be looking at the charging lever. Not going to go too much into it, keep this short and sweet. The only thing I will say is that obviously during some parts of this video series I'll be using tools that a lot of people don't have. Specifically in this case the machine lathe for doing the rod and plastic parts. Not much I can do about that, just substitute in as necessary. It's not strictly required, certainly not for this part anyway, so yeah. Alright then, let's get on with it. Okay, so first thing to do is to make the body that the plunger mechanism can slide around in. It's fairly straightforward, just setting it up on the mill, getting it vertical, squaring off the ends, that good stuff. Now to cut the actual slot, you need to get right into the center of the pipe, or as close as you can get within reason, given that PVC pipe isn't exactly manufactured to thousandth tolerances. This is an edge finder, which is like a sprung head. It spins concentrically until it hits the edge of an object, and then it pops out, as you can see there. And just by measuring the point at which it pops out a few times, I can find pretty accurately the exact edge of that workpiece there, and then just by dividing the diameter of the edge finder head and the workpiece diameter in half, then I can obviously find the center of the workpiece and line up the lathe head or mill head with it. Originally I tried to do a full depth pass on this slot, but at this point in the build I don't yet have a machining vise. It just kept moving the pipe around, so I ended up doing it in about, I think, 4 passes it was. That was the reason for the multiple different setups you saw there. It was all aiming towards the same goal, and eventually I got there. Once the body's done, you have the dimensions to do the plunger fittings, so that's the next part. I'm making these out of Delrin, just black Delrin. The first one here is the actual, I suppose, piston head. Not that it compresses anything, but it actually fits over the plunger rod and keeps it centered and concentric within the body of the mechanism. It's pretty straightforward, just turning it to a size that'll allow it to move freely and then drilling it out to a size that will allow it to fit pretty tightly onto the rod. And this one is the front plug. This is like the stop, essentially, that the plunger hits into. It doesn't have a complete through hole, just enough for the rod to seat into. And that super fine threading is for the glue to grab at it. Obviously the rear plug is basically the same, but has a through hole so that the plunger rod can go all the way through. Speaking of the plunger rod, that's the next thing on the list. I'm working on this outside in because I have space requirements. Obviously, if volume is slightly less critical for you, then you could actually do this part first and then build everything on top of it. But in the BR85 space is at a bit of a premium, so this is the way I'm doing it. This is just 303 stainless. 303 is free machining, got sulfur added to it to make it easier to deal with, doesn't work harden so easily, and is generally just a little bit nicer on your tools than 304 or 316 or whatever would be. That's not to say you can use any old tool with it, as you'll see in a few minutes, but generally speaking, it's easier to use 303 when you can get away with it. As you can see here, it's generally better when you're trying to turn a long section of a relatively narrow object, or at least in terms of aspect ratio. It's a lot longer than it is wide. It's generally a good plan to support it from both ends. Otherwise, there's a good chance the cutting forces will actually just bend it. I'm taking pretty light cuts as well, just to be on the safe side. Plus, in terms of this, it doesn't actually need to be a huge difference between the thickness of the rod to slide through the 1/4 inch hole and the thickness of the rod to actually press fit into the 1/4 inch hole. Only needs to be probably about 20 thou difference. What you see in here is what I was referencing earlier when I said not all tools will work on 303. That's a pretty low grade of HSS in that cutoff blade, and it's really just not enough to do much more than aluminum and other soft non-ferrous metals. But that's what hacksaws are for, so it works out okay. You just gotta clean up the lathe bed afterwards. You don't want those powdery bits getting ground in under the carriage and storing up the ground surfaces. Now you'll notice that what I was originally making looks like this, but that isn't actually the final design of what I ended up going with, because that's a stationary design intended to have a carriage that moves back and forth, but I found that the carriage had to be really long to remain stable whilst racking it. So I ended up going with a different design that looks like this, which actually moves back and forth itself into the front of the stock. For some reason, most of the machining of it didn't get recorded, so I ended up having to use the other for illustrative purposes. The easiest way to connect this plunger to the charging lever grip was just a 832 machine screw. Number 8 screws about 1/8 of an inch in diameter, so that works out pretty well based on the scale of the model. I used a number 29 number drill bit and then followed that with 832 taper tap, and then I think I double checked the threads with an 832 plug tap as well, just to make sure it had gone all the way through. You can see me backing off a lot. You've got to be careful when you're doing relatively thin holes in hard materials like stainless. It's very easy to break a tap. Next I have to drill the through hole for the machine screw to come out of the piston head, where it's connected to the rod. Simple enough to line up where it's going to be pushed up against the body of the plunger. Then while I was on, I decided to turn a little aluminum spacer, I suppose you would call it. It's intended to give the appearance of a 1/4 inch shaft, which is what the actual model had on the charging lever handle. The grip went into a 1/4 inch shaft, so this is sort of just giving that appearance as it comes out of the body. You shouldn't really be able to see it inside, but I figured it was minimal work for some kind of payoff if someone happens to be peering down in there. You'll notice here I use the 60-degree stub drills even when I'm not actually intending to use the live center. That's just because drill bits have a tendency to wander a little bit, and you really want concentric central holes. So it's a good plan to use as short and stubby a drill bit as you can, at least to get the hole started. There you can see the crappy M2 HSS cutoff bit actually working on the relatively low-grade aluminum. Alright, we're finally getting somewhere. We can start assembling this thing. You'll notice the spring there. I wound that myself from piano wire, which is like a high carbon spring steel drawn out into wires. I'll do a separate video on spring making. It's pretty straightforward. Also, you can see I tapped the through hole in the aluminum spacer there, and it's just to make that little bit there look nice. And there it is, the actual operation. All that work for something so simple. Since the end of that has to get epoxied into the charging lever grip, gotta cut the screw head off. And then it's time to carve up the body, as nice and smooth as it was, to start attaching all the fiberglass and roughing it up for mechanical bonding. Onto the fiberglassing. I actually like fiberglassing. I find it pretty quick and easy. I know other people have had issues with it, but I don't know, it seems to work out for me. Well, for the most part. Sometimes, like what's about to happen here, it can just not happen. Yeah. But once you're underway and it starts going right, then it's a pretty quick and smooth workflow. This is a two-part process. One is to mechanically bond the ends on, because Delrin really doesn't want to stick to anything, no matter what glue you use. So I actually decided to put the fiberglass over the end to mechanically lock it on. And then, as you can see, I'm deliberately being rough with it, so that in the next part, when I'm fastening it in, the glue actually has something to catch onto. Once the polyester resin has set, it's time to trim up the fiberglass layup to allow the actual mechanism to function. Cut the hole in the end for the rod to come out of, get it out of the way of the slot itself, all that stuff, whilst simultaneously making sure you're not cutting so far into it that it'll start working itself loose, or operation of the mechanism will push it loose. Then you've got to fit it inside the Rotocast resin pod, which is easier said than done. This took a while, probably several hours of cutting and filing and fitting and adjusting. A lot more time than I've indicated here, but it's just a kind of trial and error thing. Every project will be different on that score. This was, in fact, as messy as it seems in this video. There were clouds of resin dust everywhere, all over me, all over the work surface, all over the floor, floating around in the air, everywhere. The rod bending with the pliers there was actually not so much because of the orientation of the installation as the actual height of the installation. It's so close to the top of the actual part that I had to bend it down so that it would still come out of the slot, and all importantly, come out of the slot at the right angle, perpendicular to that facet. Because I ground away a whole bunch of resin inside, there were actually quite a lot of rough surfaces, so it was a pretty simple job of just filling the whole thing with hot glue and letting it catch on the part and the fiberglass. And it shouldn't be able to slide back and forth either, due to all those ribs that I cut into the PVC body itself. And once the hot glue is dry, it's just a case of trimming down the excess overflow. Because the body parts fit together quite tightly, it's important that every surface is exactly as flat and clean as it was in the original cast. The disadvantage here of mounting this thing with hot glue, of course, is that in the summer in hot climates it may soften and want to jiggle about. I don't think that should be too much of an issue with this particular build. But if that does apply to you, then something better would probably be like a urethane expanding foam, whether canned or two-part. Either way, just something sticky that will also take up the space and actually lock the assembly into position. This is a little sneak peek of a video from further along in the series, showing how it all assembles together and looks at the very end. Just drilled and epoxied the grip on there and then cleaned up the excess. And then that's it, we're done. Alright, I hope that was helpful and informative. And I know what you're thinking, you're all like, well, it's okay if you have machine tools, but like, what are the rest of us supposed to do? But realistically, I don't think it's actually required. I mean, maybe a drill press, but if you replace the Delrin with, say, cast resin, like urethane resin in lubed PVC pipes, you could probably use that to plug the ends and use that as the plunger, and then you could just drill into there for the rod, and that would be it. It would be pretty straightforward. Yeah, the spring video I'll get on with pretty soon. I've got a few more things to shoot for that because I'm trying to put information in it so it's not just specific to one project. And yeah, so I don't remember what project is coming up in the BR85 series. Oh, I think it might be the stock and magazine, possibly. So magnets and that kind of thing. Yeah, I think that's it. So I hope this was helpful and that you enjoyed it, and I hope to see you in the next video. Thanks for watching.